So anabolic cellular signaling part 6. So this is the 6th lecture on mTOR, and we're just going to start where we left off last time. Okay, the chat box is open, and mTOR, it's turned on. It's turned on by need, right? So whether that's chemically, just kind of the flag waving is a chemical one, if it's chemically indicated, or if it is mechanically transmitted nutrition. So what you're putting in your mouth is going to help activate it, and then the assumption of nutrition. And you know this stuff. You know a bunch of chemicals. You know a bunch of hormones. You know a bunch of. We haven't talked about all of these yet, but you know a bunch of drugs and supplements, and whether it's amino acids, right? It's leucine, it's lysine, it's arginine, methionine, and then everything else, the 20 amino acids all matter. But those are the kind of big players on the team. Those are the all stars on the team that everyone pays attention to and collects their whatever sports cards. And then the mechanical transducers, cadherins, titin, and integrins. Integrins is that's the big one there. And AMPK regulated by a ton of things. AMPK is so tightly regulated, and that question of is it friend or foe, so there's stuff that's going to activate or inhibit AMPK. It's neither friend nor foe. It really is friend, but it's sort of a wrecking ball that you have to learn how to use, or you have to learn how to um, whatever license that you would get. You have to learn to operate heavy machinery before you can use AMPK in an advantageous way. But it's always there doing its regulation. Now AMPK has a lot of metabolic functions. It does a ton of things, and the overall idea of AMPK is it's going to promote ATP. It's going to promote the accumulation of ATP, and you don't need to remember this particular part, but it sort of depends on where you are, what cell you're in. Are you in an adipocyte? Are you in the liver? Are you in muscle? And it can have inhibitory. Not everyone finds this. Not everyone finds this, but there are some studies that have found AMPK to have an inhibitory effect in adipocytes on hormone sensitive lipase. But hormone sensitive lipase and lipolysis, they have a complicated relationship. Back on in the Facebook original days, maybe you can still do this, something, what's your relationship status? It's complicated. I think that's really the relationship status with AMPK and hormone sensitive lipase. PKA can activate, I think, crosstalk, right? It can activate AMPK, and they can have opposing effects on hormone sensitive lipase, right? PKA and AMPK can have these opposing effects. But think about IGF-1 for a second. What does IGF-1 do? Well, it's for growth. IGF-1 it's very anabolic, it's going to make you grow. Yeah, but IGF-1 also inhibits growth hormone releasing hormone. So IGF-1 is an inhibitor of growth hormone release. So it's about regulation, and it depends on contexts and what your metabolism is doing at the time. So is IGF inhibiting growth? Well, yeah, there's a pathway where you can say it's inhibiting growth hormone release because it inhibits growth hormone releasing hormone, but that's not really what it's doing. And so you can look at this regulatory function, this complicated relationship between AMPK and hormone sensitive lipase, and this isn't found in every article, and sort of depends on how it's discovered, but complicated relationship between PKA and AMPK and hormone sensitive lipase. But also you'll see this activation of adipose triglyceride lipase. But AMPK, what are its huge roles? Well, it's to promote ATP creating things. AMPK promotes pathways that are going to increase ATP levels. In part, that's eating. Let's have you eat more calories, put more calories in your mouth. We can make some ATP out of that. So appetite, if something increases AMPK in the hypothalamus, you're going to eat more. Now, in the periphery, if you're in muscle or something, like, okay, our ATP levels are low. That ATP AMP ratio is falling, right? ATP levels are going down a little bit. AMP levels are going way up. That ratio is changing. We need to fix that. We need to turn off energy consuming processes like protein translation, really expensive. But we need to turn up ATP generating processes. So that's glycolysis. That's certainly the oxidation of your fats. That is the breakdown of proteins. If we're going to degrade some proteins, but you're also going to create more mitochondrial biogenesis. You'll see that little piece down here. So get a bunch of carbs into the cell, break those carbs down, and turn off mTOR. So the character of AMPK should be familiar to you. The personality, the character, the type of behavior that it has. Now, there are some counterintuitive things. The relationship with AMPK and hormone sensitive lipase can be a little bit counterintuitive, but if you just think of regulatory functions, it starts to make a little bit more sense. Now, AMPK turns on atrophy, right? It turns off mTOR. So it turns off mTOR and it turns on protein degradation. So ULK1 and FOXO, so the lysosomal system and the ubiquitin proteasome system. We're going to turn on protein degradation, but we're going to turn off protein translation. So if you turn on AMPK, if you activate your AMPK, AMP activated protein kinase, activate it, and you're going to induce atrophy, and that's been observed. So that's where we've been. That's our brief recap sequence. And as we move forward, applications, considerations, employments of AMPK, stuff to think about. And the first, probably most important thing to think about with AMPK, I portray it as the villain, but it's a gray character. It's a morally gray character. It's a Lannister from Game of Thrones, right? It's not all good, but it's not all bad, right? So there's good and sort of corruptions of athleticism and enhancements of longevity at the same time. So lifespan. Now, a lot of these studies, a lot of the kind of lifespan and how long are you going to live? I mean, we're looking at yeast sometimes and mice and yeast and maybe a mouse with a yeast infection, but it's reasonable to generalize to people given the nature of a lot of these findings. It's reasonable to generalize to people. Now, we know that AMPK and its inhibition of mTOR is going to ruin your athleticism, right? Not your aerobic metabolism, but your anaerobic stuff, your explosive, your strength, your power output. But you're going to live longer. No one's going to pick you for the kickball team, but you will be on the sidelines for many more years than the players have in life. So lifespan, very helpful. Cardiovascular parameters. So this is the kidney's long-term control over blood pressure. Don't memorize it. Just think for AMPK and its good qualities, just think lifespan, warding off cancer and heart disease. But as an example of something specific, where mTOR, a relationship between AMPK and mTOR, where they are exerting some of their health effect, is the kidney's long-term control over blood pressure. So the renin, angiotensin, aldosterone system, you have renin, the kidney's going to squirt that thing out in response to low blood pressure, or if you just have like if your kidneys are not functioning appropriately, if regulatory problems. But in response to low blood pressure, the kidneys squirt out some renin, and that converts angiotensinogen, which comes from the liver, into angiotensin 1. Angiotensin 1 doesn't really do anything. ACE, angiotensin converting enzyme, is going to convert that 1 into 2, angiotensin 1 into 2. And now we start to vasoconstrict, right? Blood pressure goes up. We're vasoconstricting. Blood pressure goes up. But it also activates aldosterone, which is fluid retention. Let's increase some blood volume. And so this is the kidney's long-term regulation over blood pressure. And when we start to see AMPK and mTOR having interactions with this blood pressure response, some back and forth with the renin, angiotensin, aldosterone system, we see one of the mechanisms of cardiovascular health, where AMPK can enhance and mTOR can potentially inhibit or impair, ruin mTOR and vascular disease. If you just give patients rapamycin, you can resolve some cardiovascular, at least improve, maybe not eradicate or totally resolve, but you can improve some cardiovascular complications with the administration of rapamycin, which, as you know, major mTOR inhibitor, mammalian target of rapamycin. And so the FKBP12 would be the target. More general health, enlargement of the heart, rapamycin can help with that as well. Cardiac hypertrophy. So rapamycin is the only thing it's really doing here is not the only thing it's doing, but among its many effects is a lot of this growth, right? And let's inhibit cardiac growth. This is healthful. Rapamycin is a very useful, healthful drug. Now, AMPK, let's consider diabetes. I mean, the prevalence of diabetes is worth considering, And AMPK and insulin both regulate glucose uptake. And this article, this is just my little, writing it out, but it's not in this article. But this article it talks a little bit about AMPK and its regulatory functions, and just a little commentary about activation of AMPK, where ATP go through hydrolysis, ATP hydrolysis using ATPase or ADP, two ADPs. You can adenylate kinase into one AMP and one ATP. So you get one ATP back, but you also get one AMP. AMP binds to that gamma subunit on AMPK, which permits the upstream activation by LKB1, liver kinase B1, but don't think of it as a liver thing, on the alpha subunit. Now, if there's a bunch of carbs, you're looking at the beta subunit for carbs, but now we have AMPK. Now, PKB, GSK3, these also have AMPK, just more direct AMPK effects. But when you look at the full map of comparing AMPK and insulin, we have non-insulin dependent glucose uptake. Or over here, I'm sorry, insulin dependent. This is no exercise. So this is insulin dependent glucose uptake on the left. So we have insulin binds to an insulin receptor. There's your insulin receptor substrate. There's PI3K. We convert PIP2 into PIP3. That's what PI3K is doing. That allows PDK to activate PKB. PKB is mobilizing GLUT4, translocating GLUT4, right? So we can call in sugar, but it's also turning on glycogen synthase, right? Turning off the thing that's turning it off. So insulin, so no exercise, you eat carbs, you get insulin, and insulin mobilizes GLUT4 and turns on glycogen synthase. Now, exercise, non-insulin dependent glucose uptake. Over here on the right, AMPK dependent glucose uptake. Not insulin, you're exercising. You don't need insulin if you're exercising. So we go through this, we activate our AMPK. AMPK stops glycogen synthase, the synthesis of glycogen, but it mobilizes GLUT4 at the same time. So we're going to use our carbohydrates. We bring them into the cell and use them to make more ATP. We're going to go through glycolysis. Let's turn on hexokinase and PFK. Let's ramp up the rate of glycolysis. So it's AMPK dependent glucose uptake. This is better. AMPK is better than insulin. Now, it's not better than insulin in terms of catabolism versus anabolism, right? Insulin, this is the anabolic one. Insulin is anabolic. Yeah, let's get sugar into the cell, but let's build up our reserves. Let's build up our storage. AMPK, yeah, let's get glucose into the cell and let's consume it. Let's burn it up. Now, it's not that metabolically efficient, but just run through it. That's fine. Yeah, we're going to eat more too. I'm hungry. Whatever. So there's a difference in AMPK and insulin. Insulin is not good for if you have diabetes. I wouldn't just let me take more and more insulin. No, I'm not talking type 1 diabetes. Type 2 diabetes, I wouldn't let me just take a bigger dose of insulin so the sensitivity is I can just overpower it with a megaphone. Not helpful. Helpful is AMPK. So AMPK is very useful in some of these conditions. Now, healing, there's some evidence that in the presence of an injury, let's say it's like you have some laceration or something like that, early healing, maybe you can enhance it. Vascular endothelial growth factor and angiogenesis, and let's get a blood supply here, and let's send some of those. Remember when we were talking in last section, the physiological stages of healing and all the chemotaxis and all. There's evidence that AMPK might enhance some early healing, and especially if you look at like diabetes healing. This is wound closure, but if you just think about healing in general, poor healing. Let's add metformin. What are we doing with metformin? We're increasing AMPK because we're blocking AMP deaminase, metformin. We are blocking AMP deaminase, and so we get a buildup of AMP. We are not converting AMP to IMP and ammonia. We are retaining our AMP, and so we are activating more AMPK. And so you see an enhancement of healing in the presence of metformin, in the presence of let's get a little bit more uh, AMPK active, right? We see an enhancement of healing. These are controls up here, well-regulated stuff. And he's looking at some similar stuff over here. Okay, the controls are best, but diabetes plus metformin, you do get an improvement in a lot of these, because sort of no matter how you are looking at it, these vascular variables, that you will see an improvement, early healing with AMPK. Now, terminal healing, maybe, I don't know, terminal healing, maybe, because you know the mechanism here, the mechanism is that AMPK is going to inhibit protein translation. For the final stages of healing, you got to translate a lot of proteins. Or you got to lay down some new meat in there if you want to heal well. And so late stages of healing, AMPK is likely to play an inhibitory role. Early stages of healing, AMPK is likely to enhance a little bit, be of some value. And so, metformin induces apoptosis. And when we're looking at cell death in these things, like that's not really healing. Right? That's not producing more living tissue. This is cell death and atrophy and narrative version, same thing, but just looking at the narrative version from that same article about AMPK's relationship in some of these. Okay, let's get to the weight room. Let's get to exercise. Let's get to prescriptive uh, domains. Now, eccentric or eccentric versus concentric. Eccentric loading works better. It just works way better. And so if you look here, there's control that's like don't do anything. Passive stretching. Now let's get a bunch of MAPK signaling. You know what MAPK is: ERK, MAPK, RSK. That parallel road to I5 to PI3K, PKP. Crosstalk and convergence at the downstream targets. But MAPK activation, eccentric loading, that's what's doing it, right? Isometric, sure, a little bit. Concentric, I don't know how much going on there, right? So you know the difference between concentric and eccentric, like the eccentric, right? Eccentric, you're stretching against a load. The muscle is trying to contract, and while it's attempting to contract, it's being lengthened. That is getting all of this MAPK activation. Control, passive stretch, that doesn't really do much. Concentric, you might as well just go stretching if that's all you're going to do. Isometric, a little bit more. Now a there is an eccentric piece to isometric. At the onset, you're contracting in the middle, and at the origin and insertion, you are seeing a little bit of stretching. The muscle does not wholly. Just you can just look at your arm and just sort of flex, and you can see there's an eccentric piece. But isometric is much higher than concentric in these things. And same article, just sort of explaining. They're looking at a rat plantaris, but this is going to work in pretty much everything. PLA2, phospholipase A2, that is going to, the more damage you get, the more active you are going to have this chemical response that we've been talking about. The chemical response, the immune system response, PLA2 releasing arachidonic acid from a phospholipid bilayer, cyclooxygenase converting it into prostaglandins, and prostaglandins signaling through that MAPK pathway. IL-2, IL-15, these are released in greater excess with eccentric loading compared to concentric. So letting the weight down is the more important immune system response. And you would know this just by experience alone. Alfredson protocol, right? The eccentrically loaded calf is the painful one. The concentric one feels fine tomorrow. It might burn a little bit during, we'll talk about that, but you already know the answer of a bunch of hydrogen ions building up from a ton of ATP hydrolysis. But the eccentric loading, that is the thing that really releases a bunch of um, prostaglandins and all that damage. They tear up the sarcolemma and the IL-2, IL-15, these markers of tissue damage. That's eccentric loading, and that's why you get so sore off of that piece. If you go to the gym and you don't get sore, you're not initiating a lot of mTOR signaling. And so that's Olympic lifting. Those guys usually don't get that big, and gals, the people who do that don't usually get all that big. And people who do pure concentric stuff, just the growth rate is very small. Curves is that gym. You've all seen the font. Curves is that gym that female only, women only are allowed in curves. And I've been to one. My name's Courtney. I can get in the door. I actually went in the back door and took a look around because it was the neighbor of a different gym where I worked out. And I think I still worked at the time at this gym. And I went in the back door of the curves next door and introduced myself. And it was all concentric, every single machine. And then I later learned that that's the curves way. It's circuit training, and you just go, 30 seconds here, and then whatever, rest for a second, 30 seconds here, and 30 seconds here. But the bicep curls are the same thing as a tricep press down on one machine. You curl in and then push down, and then a curl in and push down, and then you get to a row slash press. You press it, and then you row it, and then you press and pull and press and pull. It's concentric only. Nobody's going to get sore off that. You don't get sore on concentric. You get sore on the eccentric loading. So at curves, nobody's getting sore. So are you expecting to see meat development in curves? Well, no. But there's reason to do it, right? There's a lot of calories burned. There's neuromuscular adaptation. There's Wolff's Law, bone density perks. There's a lot of perks to it, and potentially some hormonal perks. But eccentric loading that's where you're going to get a lot of this immune system response. Same thing with the stretch activated channels, the intracellular calcium. You're looking at more PKB activation, and eccentric loads seem to be ideal for that one. And MGF is mechano growth factor. So triggering insulin-like growth factor, mechano growth factor, getting this autocrine version of it. It's not released from the liver and put into endocrine circulation, but it's the autocrine version, mechano growth factor. The muscles themselves are releasing this and profiting from it. So concentric, not all that helpful. Eccentric, you're getting more mechano growth factor. Mechano growth factor seems to be a trigger. Now, there's a lot of triggers for these things of, get a bunch of lactate elevations, which just means sort of volume training, high intensity with volume and set after set. So there's a lot of triggers to a lot of these hormones, or this growth hormone, testosterone, mechano growth factor. But for mechano growth factor, the amount of damage does seem to play a predictive role in how much gets released. So MGF, that local growth factor, insulin-like growth factor. And this one is looking at myostatin. So we know myostatin is an inhibitor of PKB. What you want in your workout is to reduce myostatin, to get the greatest reduction in myostatin that you can. How do you do that? Well, eccentric loading is the best at it. So not only is that type of loading ideal for increasing MGF, it's also ideal for decreasing myostatin. So another way, now we're withdrawing inhibition from PKB. Before we were just activating it, but we're activating it through so many different ways from eccentric loading. So if one of these maybe is not playing out all that well, there's other ones to pick up the tab. And integrin signaling, this will be the last one of to say that eccentric loading is what you want to do if you want to grow. You can just leave concentrics behind. And for pull-ups, just jump. Who cares? You don't have to pull yourself up. It's just let downs. That's really what you're doing. If you want to grow and, for the lat spread or whatever, just let yourself down, jump out, and concentric just doesn't matter. Now, it's not that it doesn't matter for anything. As I just said, curves is valuable. Curves elicits a lot of physiological and kind of neurophysiological so there's all sorts of benefits to curves, just like there's benefits to the pull up. but it's the let down is really where you're growing. And mechanical loading does some of that as well. You're going to get more integrin signaling, more mechanical signaling with eccentric as opposed to concentric, E as opposed to con, and it's quite a bit, fourfold greater. So there's a much higher mechanical response. There's a higher chemical response. There's a better endocrinological response. Everything but nutrition. Right, all of these upstream inputs. You have these four upstream inputs: the endocrine response, the chemical response, the immune chemical, um, the mechanical triggers, and nutritional triggers. Three out of those four are so responsive to eccentric loading. And so in a weight room, if you want to grow, just do that. Enough with all the concentric stuff that's just like stressing people out, stressing out the tissues, and all the grunting. Nobody's grunting on the way down. It's just a bunch of like screaming and grunting and to do the pointless part. I mean, I don't care. Cheat. Like the people who swing the dumbbells up on a bicep curl, like, oh, what a cheater. They're cheating themselves of results. No, they're not. They're not cheating themselves. They're eliminating the worthless. It's not worthless, but you get what I'm saying. I say with some exaggeration or jest that the worthless part of the exercise is cheating the weight up. Who cares? Let it down, slow and controlled, and allow the tissue to experience the full mechanical load on the way down. Flex the antagonist on the way down. If you're doing bicep curls on the way down, flex your tricep. Use your knee and physics to get the weight up. Totally fine. On the way down, flex your tricep a little. Add some additional resistance. Throw in an antagonist. In that. Now, if you're looking for ways of overreaching and ultimately overtraining, you have found them. Consistent damage and then not allowing yourself ample time or nutrition or rest to recover, that's bad. But use this as a tool, incorporate this, and feel free to cheat on the way up all you want. Now, if you're just a strength athlete and you're looking at power to weight ratio, well, now, I mean, don't do anything eccentric. I mean, just 100% Proteus where there's no eccentric loading. Use Proteus and just do 100% concentric for the neuromuscular adaptations. So neuromuscular and quality of proteins maybe a little bit, but the contractile properties much more. Speed of contraction, what I just said, go nice, slow, and controlled on the way down, because there's some evidence that slow eccentric loading compared to fast eccentric loading, we're getting more MGF, more mechano growth factor. So depending on this is the rate of deceleration, the rate of, not deceleration, but the rate of extension, 30 degrees per second versus 210. And we're looking at more mechano growth factor and slower negatives, right? Slower eccentric lows, slower negatives. There's more mechano growth factor being released. Now, I'm not saying this is the end all. This is one study. This is one study showing that, but it also makes sense. It makes physiological sense at the same time. Size principle. We all know what size principle is. And I talked about this last lecture, the lecture before or something, the all or none principle and size principle, when you put these two together, you realize that if each one of these is a motor unit, right? So this is a motor nerve, and every single fiber that nerve activates. This is a motor unit, right? Is a motor nerve, and every single fiber it's activating. This is a motor unit, and this is a motor unit, and this is a motor unit, meaning there's a bunch of muscle fibers and one motor nerve. This person isn't doing anything right here. I mean, she's like leaning forward. If she's anything, she's helping these people out. But it appears that she's just doing nothing. And maybe she's pulling down on it, and this person has to like correct that and pull up. These people are working pretty hard. I don't know about this person. This person's maybe smiling a little bit too much, but maybe that's but you get the idea. Some people are working harder than others here. Pajama pants, she's not contributing. So this is an unactivated motor nerve. This is a motor nerve that's just there for the ride. If the lady folk pull harder and the guys come tumbling forward and tug of war is won over here, she doesn't get to claim credit because she was not electrically activated. She did not contribute. Now, who wins, right? Who cashes in on the spoils of victory? Well, the people who polled, the people who contributed, they're the victors. The person who doesn't do anything, she doesn't get to celebrate in tug of war, maybe, but not really in the body, because her actin and myosin weren't contributing, right? She is not having this structural tension. She's just along for the ride. Her metabolism isn't stressed, and so specificity of adaptation. Why? What reason would you have to reinforce this tissue when it didn't even do anything? It's not contributing. Why would you do that? If it doesn't rain, why would you reinforce your house against a flood? It's not even wet. It's Arizona outside. It's like it hasn't been wet in 10 years. And why are you like flood safety, like you're building a moat and retaining walls and whatever around you? Why are you doing that in Arizona? There's no point. It's expensive to adapt. Now, this guy, he's going to sprain his ankles and mess up his shoulder. And so he's going to be reinforced by that. It's the same thing in the body. Now, there's going to be a little bit of overlap. There's going to be some endocrinological overlap, but in the body, you are going to have within a tissue, within muscle, the fibers that contribute to a cause are those that really cash in on the reward of that cause. Now, this is just saying, what are the characteristics of exercise? What are the general characteristics of exercise that are going to elicit a big endocrine response? And you have a minimum threshold you have to cross for intensity. But if you do maximum intensity for 20 seconds and then you wait for 10 minutes, you're not going to get the hormonal response. The growth hormones we talked about, it's not just the one, growth hormone. The aggregates are doing a lot, but growth hormone and testosterone, IGF, and we have all of these hormonal responses, but high volume, set after set after set, moderate to high intensity, can't be low intensity. I'll talk about that in just a second. Can't be low intensity. You have to sort of cross an intensity threshold. Shorter rest intervals. Let's get a lot of lactate accumulated. We don't want to sort of buffer and buffer after every single set. And large muscle mass, high threshold motor units if possible, and large muscle masses. That's how we're going to get the most hormonal, the biggest hormonal response to that stress. Now, low load hydration, you are not going to get phosphorylation of mTOR, P70SSK. Low load hydration, not going to do it. You do need a high load. There has to be a high threshold motor units. There has to be a stimulus that's an intensity worthy of adaptation. Low load is just not really dangerous. It's not hard on the muscle. Think specificity of adaptation. If you can already do this, why adapt? The reason we're adapting is for fitness, and you're already fit to do a low load. You go for a walk, you're not going to grow your legs on a walk. It's like, whoa, my glutes and quads and hammies have gotten huge. My calves are enormous because I just walked for 10 hours. That's not how it works, right? You're going to get lean on that, but you need a higher load. So a high load in a short duration will work, but a longer duration is really what's going to get the hormonal response for this sort of persistent activation. Now, if you're going to use a low load, it is possible, and I referenced this earlier, it is possible using a low load to activate mTOR and just blood flow restriction. So there's some evidence that using blood flow restriction is going to elicit an mTOR response, even in the presence of a low load. Now it's going to be a lot more glycolytic, right? So you're going to have a lower oxygen availability if you occlude blood flow, right? Get your rubber thing and like whatever, tie it around your arm and restrict any blood flow. You're also at that same time, you are restricting you are stopping blood flow from exiting. So not only are you preventing oxygen from getting in, you're stopping blood flow from exiting. You're going to get more of a pump, reason for MAPK activation. And so that seems to be what you get when you do the blood flow restriction with a lighter weight is growth hormone and MAPK. Remember, growth hormone, one of those major triggers is this assumption, this uh like chemical impression of high intensity, a bunch of lactate and a pH change, and this constitution is going to trigger growth hormone, but you also get a big pump and you're going to get some MAPK activation that way. um, it works, right? It works. But think about specificity of adaptation, where the strength that you're going to get from that program, right? If you tie off your arms and then go do a bunch of curls, the strength response you're going to get from that isn't that good, right? Specificity of adaptation. Why would you get super strong when you're lifting little light weights? It doesn't make any sense. The body isn't going to do it, but you can experience some hypertrophy there. And in part of it, like ischemia, reperfusion injury. And so what I wouldn't do is have the 80-year-old who has 6 risk factors for cardiovascular adverse events go, all right, I'm just going to tie off a bunch of your limbs and then pull them off and see how you cope. I wouldn't do that, but this is something that you can incorporate. If I can't. If I go heavy, my elbows are messed up. I go over about 20 pounds, my elbows are giving me so many problems. Okay, fine. Yeah, to just tie yourself off and go 15 pounds and just do nice controlled eccentric reps. And yeah, with blood flow restriction you can see activation, and you're going to see a lot of additional MAPK, mitogen activated protein kinase. That's mostly what you're going to see. um, Growth hormone response, so this is BFR, is blood flow restriction, and you do see an additional growth hormone response. And cortisol is going to go up too. Now cortisol we're going to talk about more, but um, adrenal cortex, right? This is a steroid hormone. Cortisol is a steroid hormone, and corticosteroid. It's a cholesterol derived hormone from the adrenal cortex, cortisol. Is super catabolic. Cortisol, very, very catabolic. So that's going to go up too. But cortisol does go up with any resistance training, this sort of stress hormone. But this is just looking at mTOR um, with blood flow restriction compared to control. And we're getting more activation with blood flow restriction. P70S6K, same thing. So if you're seeing mTOR, that's what you'd expect. This is the MAPK one. Super active. MAPK is the most active one. Now, combining aerobic and anaerobic. So if you're going to do something aerobic and something anaerobic, you're going to do resistance training, try to get some anabolic signaling going, and prostaglandins, focal adhesion kinase, insulin-like growth factor, right? So it's FAK, that's going to be your integrins. Prostaglandins, are coming from here. PLA2 and then cyclooxygenase. Now we have prostaglandins and insulin-like growth factor from your liver or from the muscle, MGF, and interleukins 2 and 15, interferon gamma, testosterone. We have, you throw estrogen on there. And we have these anabolic inputs. We are stopping tuberin. These things are stopping the tuberous sclerosis complex, which is halting Reb from activating mTOR. And go ahead and put a lysosome down here. And Reb needs this GTP, and tuberin is converting it into GDP. It's facilitating the hydrolysis of it. And over here, we have aerobic. Now, we know what aerobic activity does, these long duration exercises where ATP, all right, we're building up a bunch of ADP, adenylyl kinase, we have a bunch of AMP. AMP activated protein kinase. So we're going to be activating our AMPK, technically LKB1, does the real activation at the alpha subunit, but the gamma subunit, that's what permits LKB1 to do the activation. And AMPK, we are turning on tuberin. We're doing the opposite of this thing. AMPK, we are inhibiting raptor, right? So we're doing the opposite of what all of these are doing with a bunch of aerobic activity. And then we're also activating lysosomal protein degradation, the ubiquitin proteasome system, to attach these ubiquitin tags to these proteins and maybe get in excess, get carried away a little bit with some of our degradation. So we have this interaction between anaerobic and aerobic, where aerobic is opposing anaerobic. So does that mean that we should not do aerobic activity if we want to grow? Maybe. It means maybe. There's plenty of literature that starts doing these combinations, aerobics and anaerobics, and let's start combining these things and see what happens. So let's go through a couple of them, starting with this one. Now, this is William Kramer. He is the biggest muscle physiologists probably on the planet, and there's people will sometimes cite this article to say, no, you can totally do concurrent strength training. So the neuromuscular adaptations are in concurrent strength and endurance training versus strength training alone. And people say like, oh, you can totally do both and grow. And they cite this paper, not quite what the paper said. So there's 21 weeks of resistance training. They were training a couple of days a week, doing the resistance training a couple of days a week, and plus stationary bike or not stationary bike, right? So we had um, previous subjects who were involved with recreational physical activity, right? Jogging, walking, some aerobics, but not strength training. Or competitive sports. So these aren't resistance trained people. These are beginners. These are people who have not been exposed to the stress before. They're recreationally active. I jog and I've been skiing on occasion, and it's not like people go skiing every single day of the year or whatever. So while there may be an anaerobic component on the slopes, I was like, oh yeah, I went skiing twice last winter. That's not really resistance training. A bunch of people who go jogging and do biking, stuff like that. Aerobically trained people who don't do resistance training, and and so they incorporate resistance training a couple of days a week, and then they look at people who are strength only and people who are strength and endurance. SE, strength and endurance, and these are strength only. And most of the variables they were measuring, they didn't see any difference. They didn't see any difference. But maximal rate of force development. So this is power. This is explosiveness. This is a baseball pitch, a shot put. Um, Throw, right, putting the shot. This is a vertical jump. This is sprint speed. So rate of maximal force development. The strength only group is better, right? The only thing that was different is they didn't do the aerobic training. And this is an article that gets cited to say that you can combine both, and aerobically demanding activities have no um, compromising effect on anaerobics, on resistance training performance. This is one of the major papers that gets cited, and it's getting inappropriately cited because the other important part is these are beginners. These are beginners, right? You expect what you would expect to see in a beginner is these lines improving, rate of force development. You would expect. Some of these people have never exercised before. You put them under the weights, and are they going to get a bunch of hypertrophy immediately? Well, no, but you expect a ton of just very rapidly onset neuromuscular adaptations, and sort of abolish that. But a lot of the literature on this subject, you have to actually read the study to understand that it's not like, remember the studies that I put up that said these studies are being cited to say that size principle, orderly recruitment, has holes in it, right? That is not really true. It's only true for beginners. Once you train, it's not true. But we went through the studies, and those studies said nothing of the sort. Not even close. Like, what are these people talking about? And you have to do the same thing with a lot of the literature that talks about it's totally fine to combine aerobics and anaerobics, because the major limitation is you're looking at beginners and strength output, and beginners are going to respond rapidly. I don't care what you're doing. Now, elite athletes, those usually don't even appear in literature, because if you have an Olympic coach or even a collegiate coach or a professional coach or something like this, and they're subjecting their athletes to inferior training, that's malpractice. The coach gets fired, right? There's a lot of money involved here. And I mean, on the subject of money, look how many COVID tests the NFL goes through. I mean, they get more than anybody. Like, every single player gets tested every single day of their lives. And like, hospitals are limited on available resources, not the NFL, right? We see these. Now, I'm not saying the NFL is doing anything too egregious or whatever. The ethics are on the line here, but what I'm saying is money, the money and victory, and you have to do anything to win. You'll do anything to win at that level, and inferior training strategies because you want to show a difference in the scholarly literature. No thanks. The coach isn't going to go for that. And so you don't see studies on elite athletes because you're not going to get a control group and a set of elite athletes. You're just going to do what you think is best. So what you get is a bunch of recreationally active college students because they were convenient. It's convenient sampling. All right, you're in my class. I'll give you 5 points extra credit if you do this thing. And that says nothing about elite or even sub-elite athletics. And so that's the primary limitation of a lot of the data that say this. But then studies like this don't even say that there isn't a difference. I mean, look at this. That's a statistically significant difference and something you would expect not to find when you combine aerobics with it. Now, this one is just a ludicrous study. I'm fully willing to just say these people, man, you just had no idea how physiology works when you designed your trial. They had 10 people. There were no lifters, moderately trained men, but they're not getting like actual lifters, and they had a contralateral limb study where the resistance and the aerobics are done on contralateral limbs. It's the same body. It's the same body. It's like, okay, so this body over on this leg, we're doing resistance training, but on this leg, we're doing resistance and aerobic training. So there's 10 people who are beginners, it's recreationally active, moderately trained. I mean, these aren't like, good athletes. 5 weeks of unilateral knee extensors. And it's so ludicrous. Okay, to think about this perspective. If I say, don't do a bunch of jogging around the time you're doing your bicep curls, if you just go jog all day, good luck making your biceps grow, right? You're going to get this AMPK activation, impairing mTOR. The physiology, the biochemistry of the inhibition. You understand how this works from a magic school bus perspective. And so why don't you just not do a ton of, you're trying to grow. It's hard to grow in every direction. It's hard to become an elite marathon runner and a power lifter at the same time. Just like, look at them, just look at the people. And when you look at an aerobic, I knew a guy, he was a rugby player, and he did this combined, he was a professional rugby player in Germany, and he did a combined marathon and bench press. I thought it was this really interesting because they were weighted. It's like, all right, what's your maximum bench press and what's your marathon time? And we're looking for sort of the decathlete, well-rounded athlete in two sports. What's your strength and what's your endurance? And he had a fair amount of endurance. I mean, what did he run under 3 hours? I doubt it. I don't remember what his marathon time was, but I mean, his bench press was 300 or something. Or Mark Van Ness. Mark Van Ness is a great example of, he has endurance. He was a great cyclist. He was a collegiate swimmer and did cat whatever cycling. I don't know the ranking systems here, but has done triathlons. I'm not sure if he's done a marathon, but has a great endurance base. He's also very strong. But Mark Van Ness compared to like a serious marathon runner, it's no comparison. Mark Van Ness compared to a competitive bench presser, it's no comparison. But can Mark outscore both of them in the marathon / bench press event? And the answer is yes. And so sort of this hybrid, you're not really excelling to this really impressive degree in other, but what's impressive is your ability to retain capacities in both domains, because the human form, the biological form, let's go further. The biological form, in order to improve in one direction, you sort of shovel from another direction. You shovel resources from one domain to lump up that mound in the other. And yeah, you can make progress in every direction a little bit, but that ceiling is low unless you start scooping from one capacity to supplement another capacity. So this idea that we can do aerobics and anaerobics because a couple of studies didn't really say so is a little bit ludicrous. Now, can a beginner experience adaptation by introducing resistance training while also doing cardiovascular activity? Yeah, of course. I'm not saying that. What I'm talking about is tinkering with your exercise prescription, those more subtle variables once you plateau, right? What do you do once you plateau? You're trained. You're not a beginner. You're well trained. You're a college athlete. You're a pro athlete. You're an Olympic athlete. Now what? Well, if Usain Bolt has been jogging, he's a shitty sprinter, right? He's going to lose. That's not how specificity of adaptation works at the level of mTOR, at the level of really anything, right? There's specificity of mechanotransduction, specificity of every physiological response. And so, can you combine aerobics and anaerobics as a beginner? Yes. Go for it. Burn a bunch of calories, expose your tissues to novel loads, apply uh, these mechanical forces to the tissues they've never seen before, and they'll respond. But once you've adapted, once you're actually, in shape, now it's time to use physiology to improve. Now, better than getting off the couch isn't good enough advice. That advice no longer helps you. You just look for somebody who actually knows physiology. And in that case, it's time to stop incorporating a bunch of um, aerobic activity with your anaerobics. Now you can go the other way. You can use heavy lunges, and if you're a cyclist, you just look at Lance Armstrong's training, and it's not as inhibitory to aerobic performance. And those athletes, those Tour de France cyclists, they need to make it up the hills, right? They need some power, and they need to pull ahead of somebody. They're drafting for a while, and now they do the let me pedal really hard and get as explosive as possible. And so there are components of aerobic sports, the kick, the hill, whatever it is, where you're going to need a little bit of that, and it doesn't seem to impair aerobic signaling in the way where the aerobic signaling would impair anabolic cascades. Now, everything, specificity of adaptation, this is just everything. Name a tissue, and it's going to respond according to the laws of specificity. So even if it's a blood vessel, well, what does the flow look like? Is it smooth, right? Is it rapids, oscillatories? Or do you have this sort of rough blood flow going? Then there are different mechanical forces that a blood vessel is going to respond to, and the adaptation is going to respond accordingly. Is this when periodization of training would be a smart approach? Yes, very important periodization piece. Now, the average person doesn't really need periodization. If it's just like, I'm lifting to be healthy, and I'm a 52-year-old man who works at the whatever, like a funeral parlor, and I'm afraid of becoming one of my clients, and I just want to be healthy. And so, okay, well, don't do periodization. Just go do stuff. Go do stuff and do it repeatedly enough. Um, there's a lot of training programs that are just trying to be so novel, and just like every time you go work out, you do something totally different. That's okay. You're not exposing the tissue to repeated stresses enough. So this like every single time I do anything is totally different. CrossFit does a little bit of that. We're supposed to too novel every time. Like, okay, like when are you going to repeat? Um, and so not all CrossFit, but there are components of CrossFit where the novelty maybe gets out of hand. What you want to do is repeated stresses for a while, and then do a periodized so I'm going to expose my tissue to this, and then so that my tissue knows I'm going to be exposing it to it again, I'm going to do it again and again and again and again, and then my mTOR signaling is like, all right, it's time. I get it. It's time to actually grow. It's not time to just build back to where it was and hope I don't experience this again. It's time to actually, enough with the sandbags. Let's reinforce our house to real floods. Put it up on stilts or whatever. So that you need some repeat exposures, but all tissues are going to respond to repeat exposures. So that question about periodization, yes, you go through periods and you want novelty, but you want to have to repeat stresses for a while. And depending on what that goal is, it could be an aerobic goal for a while, and then it could be a get strong goal, and it could be a speed goal or something. And sometimes there's overlap in goals, that non-linear periodization. There can be uh, overlap in goals, but kind of sequestering your progress. What I wouldn't do is have two things that totally oppose each other. All right, I am activating AMPK and PKB both. I mean, it's just like, what, you're not. That's not helping. That's not the most helpful way of doing things. And just cells are going to adapt the C2, C12. This is this immortalized mouse myoblast line. It doesn't really matter, but you just look at these different types of stresses that you're going to put on these, and a myotube, a developing muscle fiber. The different stresses that you put on these things is going to elicit different cell signaling cascades in the body, right? A uniaxial versus a multi-axial load, it responds differently. The very nature of the stress. And so let's say you're working out, you're doing bicep curls. What are you doing? Hammer curls? Are you doing barbell curls? Are you doing dumbbell where your wrist rotates? Are you doing the easy bar? Are you doing reverse curls? Are you doing preacher curls? Are you doing with the rope curls on the cable cross machine? Are you doing what is it that you're doing? Because the load is going to be applied differently. Remember earlier the trampoline example, mechano transducers, right? So we're going to have these proteins that sense load, the integrins and titin and coherence, and where you jump on the trampoline and how you jump, and do you jump really high or do you cannonball, or where all of this stuff matters. And just your wrist position is sufficient to matter, but you want to expose your tissue to some repeat stresses before you go about changing it. But specificity of adaptation is so important. It's so foundational to how a body responds and the way it's exerting its response, the mechanism, the way it's carrying out its adaptation is a bunch of mTOR, largely a bunch of mTOR. If it involves proteins and tissue regeneration and remodeling and growth, hypertrophy, and the protein turnover, if specificity of adaptation involves any of that stuff, the how is largely mTOR, the management of those adaptations. And we know how it's being detected, right? Remember, need, an assumption of need, and nutrition, but is a little bit different. But the mechanical stresses, the hormonal stresses, the immunological, chemical stresses, that's how you're relaying this information to the interior of your cells through cell signaling cascades, through mTOR. That's the information your cells use to do adaptation, and it is so specific. All right, what is the chemical composition outside of this cell? What is the mechanical loading profile being imposed upon this cell? Specificity of adaptation. Now so the resistance training stimulus, you need some high forces, some high loads, especially eccentric loads, to get mTOR to be activated. P70 SSK, RPS6, ribosomal protein S6. And the aerobic stress, this isn't activating mTOR, right? You're getting mitochondrial biogenesis because that's what's really helpful for aerobic stress, oxidative stress, right? If you're running all the time, man, it would be really helpful if I had more mitochondria. Okay, let's give you more mitochondria. Specificity of adaptation, right? Let's give you the thing that would be best for the stress, for what you're applying to those cells. Now, but high loads, this is what's going to activate mTOR. So remember earlier when I said, when we were talking about Henneman's size principle, and I said need is what matters. Now, load is the best way to get to the high threshold motor units. You start low and you work your way up. Not enough, those low threshold ones. So let me ascend that ladder. Let me scale up the motor units to a higher threshold one. Not enough to heave this weight, to lift this load. So let me scale up. Let me scale up. Let me scale up. Now I've got it. And you're using a ton of tissue at this point. You don't just start with the high threshold stuff, but you can ascend Henneman's ladder. You can recruit high threshold motor units without using a really high load. You don't have to use the 95s. Maybe you can't do it with the pinks, but something between. Maybe you can hold a 15 or a 20-pound dumbbell and just hold it there for a really long time, and go do a 50 RM set, and on rep 50, yeah, you're recruiting the high threshold motor units. Does that matter? Does it matter for cell signaling, or does it matter just to execute the movement? Does it matter to just move that weight? Clearly, you want to do this thing for so long. So I guess I have to call in some additional troops. This seems silly to me, but I'm guessing because it's not ending with, food in my mouth. It's not like I didn't have to do this to wrestle the bear. I didn't have to strangle the bear for 20 minutes and then cook it and eat it, right? This doesn't end with food, but obviously you're making me do this thing. So I'm going to go ahead and allow you to use high threshold motor units, but you're not getting the same signaling. You are not getting the same mTOR signaling if you're using Henneman's size principle, high threshold motor units using the pinks. You're not going to get the same signaling. You may get the same recruitment, similar recruitment, but you're not going to get the same signaling. Specificity of adaptation. All of these characteristics. Remember when we were talking about the biomechanics section, all of these characteristics are important. The magnitude of the load, how heavy is it, the rate of application, does that thing just like race into your hand, or is it a slow onset of force? The duration of the load, where are you, and is it isometric, is it dynamic, what component of dynamic, and the range of motion you're going through, and the location of the load. Remember when we were talking in the biomechanics section about levers? Let's talk levers here with the location of the load. And so there are so many variables, and your body detects all of them. It detects and quantifies and responds to all of those variables. So just like you can't have a single like all I eat is corn dogs or whatever. Like, okay, you're missing key nutrients. If the only thing you eat is corn dogs or muffins, you're missing key nutrients, right? You need diversity of nutrition. You also need diversity of mechanical loads if you want a comprehensive tissue to be developed, right? A robust adaptation and a tissue that's broadly capable of performance or even just big, right? So you need diversity of stresses, and your cells will respond to all of these. Specificity of adaptation. How does it respond? What type of response does it mount? mTOR. mTOR signaling, cell signaling, that's how it responds to that stuff. Then we talked all about angular specificity. Again, the specificity of the length and how you respond to a length tension relationship. If this is a video, if this isn't an image, it's a video, and she just holds it there, and that's the only place she trains, she's going to get really strong right there. She's going to get isometrically strong, and if she wants to be concentrically strong, she's going to have to, and she wants to train with isometrics, she better do isometrics, like just pick every 10 degrees or something like that, and do those holds throughout the range of motion. But we know all about angular specificity. All right, well, how is this stuff adapting? Like, how are we creating these adaptations? A bunch of cell signaling. It's a bunch of cell signaling. The Alfredson protocol. Why does the Alfredson protocol work? Well, we need mechanical loading in the Achilles, right? So you're going to get a bunch of chemical responses in the soleus and in the gastroc. You're going to get a bunch of chemical responses. You're going to get inflammation up there. You're not going to get inflammation in the Achilles, though. There's no inflammation there because tendonitis isn't a real thing. What you need is appropriate mechanical loading. What type of loading does it need? Well, the eccentric is really helpful, and then if all you do is stretch, though, that those signals get loaded out, or get filtered out. But the load, it helps to have a little bit of load there to amplify that signal. And so single leg, that negative, that stretching, that eccentric force with a single leg using your whole body weight, you're going to add a little bit of a load doing that. So specificity of adaptation in general, right? There's Wolf, there's Davis, and then Andre Agassi and Mike Tyson. I always include them because Andre Agassi was jogging, just like every other pro athlete was up until, I don't know, the 90s, right? Everyone's just, and baseball players are still doing it, jogging around the ballpark and all this crazy nonsense. And what is it that you're doing? What are you accomplishing? Now, Gil Reyes was Andre Agassi's personal trainer and really intuitive guy. I don't know what his history was, and biomechanics or physiology or anything. I'm not sure if he had a background, but he's certainly intuitive, smart guy. And he said, well, how often do you run 5 miles on a tennis court? Well, you can't, right? You're like not even in the arena anymore if you run 5 miles. I'm like, I'm not even in the parking lot if I've run 5 miles. How often do you run more than 5 steps? Not very often. He talks about this conversation in his book. And this idea of sport specific training, do a task analysis and figure out what your sport calls for. You can go one step further and get into biochemistry and say, well, what you're doing, these 5 miles, are actually ruining your 5 steps. It's making you worse at performing those 5 steps. It's not just not enhancing, it's actually ruining your performance. And you can get into the interruptions of muscle recuperation, how quickly you can heal and get back on the court the next day, and you're just sort of prolonging the soreness and the broken down tissues, right? You're not ramping up recovery effectively. And this was just when you get into wolf, bones are going to adapt. And Davis was just talking about elastic tissue is going to respond to elongating forces. And so this is just, stretching and elasticity, elongation. This is bones. And Mike Tyson was contact adaptation. Now, contact adaptation, he talks about getting out of prison. He's getting in his fight with Peter McNeely, and he's with these trainers who are just kids, just has some kid, sparring with him, and he's like, I can't take it. And this is, like the greatest boxer ever can't take a punch from just some sparring partner. And because he hasn't been hit, nobody's going to hit him. He's Mike Tyson. And so he gets out of prison. He hasn't been punched in a really long time. And so contact adaptation, all of these tissues are going to adapt. And contact adaptation is an interesting one because I don't quite know how to explain it. But so getting into the nutritional piece of what do you eat to enhance or inhibit, if you want to inhibit mTOR, carbs, fats, and proteins. These affect your signaling cascades all in unique ways. These are going to affect your signaling in their own way. And so we know about carbohydrates. If you're on a ketogenic diet, you're looking at a little bit more AMPK activation. So glycogen, that's going to bind to AMPK's beta subunit. So do your carb loading, and you're going to be inhibiting your AMPK a little bit more. If you're on a ketogenic diet, you don't have that same inhibition. AMPK is likely to be more active, more inhibitory for mTOR. And so you have to, if you're on a ketogenic diet, you have to navigate this maze through some other corridors, right? Because this one's blocked off. So carbohydrate restriction, we're looking at some AMPK. With the proteins, really leucine, lysine, arginine, you can get 90% of mTOR mobility and activation, translocation to the lysosome with just those three. Methionine is also helpful. You can sense, there's a ton of sensing proteins for the proteins, both in the cell, right, in the cytosol and in the lysosome, and especially arginine in the lysosome, to get mTOR mobilized to the work site. So let's say you don't want to eat a ton of protein, and oh, my kidneys, or I'm on a calorie restriction diet, or whatever the reason is. You don't want to eat a ton of protein, or you just like, I want to preserve, I am on a weight loss diet, but I just don't want to lose all my muscle mass while I'm doing this. Fine, you know what to do. Leucine, lysine, arginine, throw these specific amino acids in to give mTOR that signal that, hey, work is calling. I sounded the alarm. You better show up to work. So introduce these, and then have some other growth factors. Your insulin, like MGF or something. Some other growth factors activating Reb, and so inhibiting tuberin, permitting Reb to activate mTOR, and so activate it from those two cascades. You don't need that many calories. You need the right stuff to be going in. And so if you want to lose weight, what a lot of people will do on a weight loss diet, on some caloric restriction, they're trying to cut weight, I'm trying to get lean, they end up just losing a ton of muscle. Because what they do is sort of silly, like, oh, let me just I'm trying to get lean, so let me do really high repetitions and sort of low weight, high reps. and let me cut back on the total amount of calories at the same time. What are you doing? If you're cutting back on your loads, you're not lifting heavy, you're not using high threshold motor units. What does that tell your body? Oh, I guess I don't need these. Like, these are pointless. And so you get this selective atrophy of the high threshold motor units. Use it or lose it, right? You're not giving your body those signals that, hey, go ahead and hang on to these. Let's see if we can cut from elsewhere. Don't cut this stuff. I know it's metabolically expensive and I'm not using it. It seems pointless. So go ahead and get rid of that, right? No, use it. Give your body the metabolic signals that those tissues are of value, that they're contributing to your day and your acquisition of sustenance, that you're using those high threshold motor units. So don't like, oh, I'm leaning up, so I'm lifting light. That's really stupid. And when people just sort of cut calories indiscriminately, oh, I'm just cutting everything. Like, whoa, hold on. Okay, we need to give our bodies the right nutrients. Now, it's harder to grow on a ketogenic diet. I've been on one for, I don't know, 2 years or something. And it's harder to maintain tissue. There's a little bit more AMPK activity. It's not impossible. You can totally do it, and you know the recipe. You know the roads to take. You know the growth factors to activate. You know the characteristics of exercise is going to activate them. You know the map. You know how to navigate it. You know the ingredients to cook up hypertrophy. You know all of this. And if you're going to cut calorie, you're like, I want to lose fat. Okay. I wouldn't cut all the fat out of your diet, right? This is you're losing your steroid hormones if you cut out a bunch of fat and cholesterol and go super high fiber and like these typical weight loss diets. Like, okay, now you're like hypogonadal, and that's not helpful for body composition. That's not helpful for fat loss. That's not helpful for muscle retention if you like hypogonadal. And so people will cut out all that stuff thinking that's helpful. Now it is helpful to reduce carbohydrates because you know how insulin is just, I mean, that is going to, the PDE signaling phosphodiesterase, the insulin activates PDE, which prevents lipolysis acutely from happening, and chronically it's impairing adipose triglyceride lipase. So these insulin responses is much better to use AMPK to do that activity. So I wouldn't do big excesses of carbohydrate in the presence of a weight loss diet, but I would keep fats and cholesterol on board, and I would definitely keep the appropriate amino acids on board. I would supplement the appropriate amino acids to get that weight loss diet to take weight from where you want it to go. Like, I want fat to be burned. Okay, let me burn all of your high threshold motor units so you have like tiny arms. Like, that's what happens when people go on these diets, often because they don't manipulate the variables correctly. They don't consider how mTOR works. They don't consider how PKA signaling works. They don't consider cell signaling cascades, cellular behavior. These things they're sort of oblivious to this stuff. And it's okay because they're majoring in other things, psychology, but you aren't majoring in sociology or religion or English or something. You're majoring in this. And so you get to know how these things affect your body, and you get to actually work with them. You get to um, tinker with these variables to elicit the outcomes that you want. And you just look at like leucine supplementation. This is really what a lot of people started with, was just leucine. Let's just look at leucine, and can we minimize autophagy and maximize hypertrophy, maximize the retention of skeletal muscle in the presence of even like cirrhosis. Can we manage these things? And P70S6K, yep, that's working really well. 4EBP1 and P70 or ribosomal protein S6, and just supplementing with leucine in like a cirrhosis population. Even in disease populations we're seeing, I see with the control too. uh, and then with testosterone and your steroid hormones, remember, these things you can uh, eliminate or at least reduce levels of steroid hormones, reduce levels of cholesterol first, and then levels of steroid hormones follow. And downstream from that, you're seeing effects on like lipoprotein lipase and mTOR signaling. And there's a lot of um, of signaling that gets compromised directly and indirectly with a low fat diet. Don't go on a low fat diet. That's not what you want to go on. Okay, let's stop there, and then we're going to pick up with supplements next time. And that was the end of me
I have a
talking.
question.
Yeah.
Okay, so okay. When we're dealing with inhibitory pathways and we traverse two pathways simultaneously, is the inhibition doubled in intensity? Is it doubled in duration? Do we see any increase in inhibition of mTOR?
If you have multiple inhibitors all doing the same thing.
Yeah, so like if I take NSAIDs and I'm doing a gross amount of duration cardio, like I immediately after my cardio, I take an NSAID. How is that going to impact mTOR?
Yeah, maybe it's a really good question, and as all of your really good questions, I have a really mediocre answer, an incomplete answer. Um, you might look at things that can inhibit, like PI3K specifically. You know, you might have something that's inhibiting that PI3K PKB pathway, but MAPK might still be going, and there might still be a convergence at the end, and so one inhibitor, well, now maybe we need a second inhibitor, you know, maybe so the example that you just gave about your running or aerobics and taking NSAIDs, that's really a way to shrink. I mean, that's a way to waste your muscle, is to do a bunch of aerobic activity and just take NSAIDs every day because of the shin splints. And multiple mechanisms there. You know, so the MAPK signaling is being compromised, but then also you're inhibiting you know, raptor and tuberin and sort of that PI3K PKB pathway. So there probably is uh, sort of a supplementary inhibition when you're combining in that way. Now, if you're combining inhibitors to sort of just do the same thing, I think just nothing changes. My hunch, nothing changes. But depending on where that inhibition resides, multiple inhibitors may exert more of an effect.
Hey, Professor. I was going to ask. So, I don't know. You always hear different things from different people regarding reps and like the pump and all that. And I guess what I was going to ask you was, we were told, I believe in ACSM2 that 20 reps is you start hitting endurance and mTOR may be deactivated, or you can just release too much cortisol. I guess what I'm trying to ask though is, like, I've seen some bodybuilders or some athletes say that they go for like 20 to 30 reps with a very light weight, and they just go for the pump and they do multiple reps. So I guess the question is 20 reps too much? Where is the cutoff point? I guess.
So yeah, there's sort of the resistance training equivalent of endurance, right? Where again, specificity of adaptation, you just have to consider, like, what are you trying to get good at? If you're doing isometrics, you're getting good at isometrics, but you're not going to get particularly good at dynamic stuff. If all you're doing is negatives, right, you're not going to get that much better at the actual pull of a pull-up. Right? If you jump and let yourself down, you're going to grow better, and you're going to get super sore the next day. But specificity of adaptation, if you're doing 20 reps in all of your sets, you're not really going to get that much stronger. You're going to get good at that endurance piece, that resistance training endurance, that ability to get through reps 15, 16, 17, and 18 without too much of a cringe. Now, is it causing hypertrophy? It just depends how many like exogenous steroids are on board and what other pathways are being. Are you eating 500 grams of protein and 1,000 grams of carbs and injecting testosterone? So yeah, you're going to grow. But for everybody else, is that effective? Not really. You want to, if you're going, let's just call it natural, even though testosterone is natural. I mean, we talk, but there must be a better word, like than androgenic, like non-exogenous androgens, whatever. If you are going about it without needles and hopefully not pills to ruin your liver. Um, the best way of doing things is just like again, that task analysis, figure out exactly what your sport or your performance calls for and replicate that thing. But if it's for growth, 20 reps, I wouldn't do that. uh, 10 rep sets, heavy high threshold motor units, allow mechanical signaling to jump hard on that trampoline. Right, go heavy and jump hard on that trampoline and do a lot of eccentric loading and 45-second rest periods or something. I wouldn't rest for 5 minutes between sets because you're not going to get the same endocrine response. But relatively short rest periods, relatively heavy weight, focus on the eccentric side of movement, and again, like just huge muscle groups. I mean, it's just little tricks you could incorporate, I guess. There's some evidence about use of tissue, electrical activation of a tissue can help facilitate binding of hormones. And so go start your legs, go do squats and deadlifts or something, and and then start incorporating some shoulders and traps. Then I see people doing shrugs. Like, I always find it just a little bit weird. Because like, what are your traps actually for? I mean, up there in your neck, I mean, you got a ton of androgen receptors, and why not just use them? Why not just use those androgen receptors and just do a bunch of legs and really get those androgens roaring, and then go start working in some shoulders and just carry around some weight with you. And people who have huge traps, yeah, they carry stuff. Deadlifters are not like, I don't see like deadlifters shrugging all the time. They're just like, they're just making sure their shoulders don't rip out, like it's the all drug Olympics, that Kevin Nealon skit. That's the farmer's walk or whatever. I mean, horrible for your back. You're going to have terrible, disc degeneration doing farmer's walks, but you get a bunch of traps and stuff. So I think I have no idea what the question is that you asked me. what is the question?
I was basically just asking. Okay, like you hear like certain like random bodybuilders that are going against the grain, like, oh, do 20 reps, do 30. I guess my question is, do you think that's legit, or do you think that these are guys who are probably on some kind of hormone? Because I know that when you're on hormones, doing a high rep is a lot better, not only due to the fact that you can heal a lot better, as we talked about in class, but the fact that your tendons don't also grow at the same rate as your muscles do. Therefore, doing a heavier load while not natural can definitely lead to a much higher risk of injury. So I guess what I was trying to ask is, do you think that these bodybuilders or these so-called bodybuilders are just a bunch of people on some kind of hormone just saying
Probably.
this?
I don't want to make accusations or
No,
anything.
I know. There's no external validity, especially if you haven't seen them. But
yeah, I have no idea who these people are, but it seems likely if people are doing all this against the grain stuff, often against the grain is there for a reason. The fundamentals are the most effective things. I mean, so what are the fundamentals of resistance training? Well, it's just whatever fundamental exercises of the lunges and squats, and I mean, you go through the actual exercise and just do like 10 reps and that works the best. The fundamentals work the best, but it's not exciting, right? It doesn't feel secretive. It doesn't feel like some mystery that somebody is keeping, and just pay me $80 an hour for personal training and I will reveal the mysteries of what your doctor doesn't want you to know about, and all that stuff. And so I think people have to pay for something. If you just pay for fundamentals, like, well, I knew that already, right? And so, oh no, you have to do 20 rep sets and do this. I doubt it. I don't really think that's true. Now, some of the fundamentals, let me apply a little caveat here. Some of the fundamentals you'll see in whether it's NSCA or ACSM, these position stance, and they talk about diminishing returns after set 3, something like that. Don't quote me exactly on what they say, but do your 3 sets of 10 and then move on to another exercise. Do 3 sets of 10 and move on, and there's diminishing returns after set of 3. But we're going back to that same flaw that we talked about in, can you combine aerobic and anaerobic? Yeah, sure, everyone responds fine. Hold on, beginners are responding with some improved strength. That's not the same thing as an elite athlete going and jogging and trying to even preserve their current status. They're going out and running the marathon and think they can maintain their bench press. So a lot of these studies, do your 3 sets of 10 and move on. You're getting diminishing returns after that. Those studies are on like recreationally active 40-year-olds or recreationally active college students. And sure, in that group, but what about the group who's totally conditioned to 3 sets of 10? Do the 4th set, then increase the load a little bit. You're going to stop adapting to things that your body can do comfortably. Now you could reduce the rest periods, you could increase the load, something like that. But you can also increase the total exposure, the total volume, the number of sets in series. And so there's like the German training, which I have no idea if this actually comes from Germany, 10 sets of 10. And man, you'll get sore and you're going to grow. But I wouldn't do that if you're a beginner. I wouldn't do that if you're recreationally active, 10 sets of 10 on squats. Okay. Now you're like in the hospital, like you got like rhabdo or something. I mean, it's like these, so I think we have to consider the actual person. We have to consider the athlete or non-athlete who is initiating exercise or who is continuing exercise before we can say, is this good? Is this just strictly indiscriminately good for everybody? Well, if it was, that would be fundamental, right? There's reps of 20 and stuff. That would be the fundamentals that ACSM and the NSCA report in their position statements and position stance. But it's not. And so there are populations for whom that might be ideal. There are populations that might be wonderful for. Task analysis, figure out what they're trying to improve, is some muscular endurance component like that critical to whatever tested performance, and so just figuring out the subjects themselves, whether it's a study or whether it's athletes or whether it's people in a weight room. Maybe it's good, maybe it's bad, maybe it's people just trying to say, like, I know the secret that your doctor doesn't, like those ridiculous things. So I don't have that good of an answer for you, but the fundamentals seem to work best. Fundamentals supplemented with sound biochemistry. That's really what effective coaching and effective training look like. I'm gonna shave. I'm getting itchy already. I feel like I just shaved.
I just did, and I had to sleep on the couch. I had like a full beard. My girlfriend did not like the fact that I trimmed.
Oh, that's funny.
she hates it.
Well, she hates that you trimmed. She wants you bearded.
And I hate facial hair. If I had it my way, no facial hair, even a little.
Like, yeah, there's a time like I was wondering, like, can I like laser this thing? I don't want to have to deal with this anymore. It would be so nice to not have to shave and like clog up my sink. It's the same thing with haircuts. I do it myself over my sink. My haircuts cost the same as Drano. Like I could buy a bottle of Drano and get through a few haircuts, or I could go pay a barber to do like small. Did you see the big game yesterday? And like all that nonsense. Like, I don't know, what game are you talking about? And to have those anonymous conversations with somebody, like, can we just sit here in silence while you make my hair look slightly less awful? So yeah, I just shave over the sink and I cut my hair over the sink and then, a little bit of Drano and I move on. But I hate the hassle of it. So if I could just laser removal, I might. But it's also like scary. I don't know.
I just have curly hair and it just grows out and then back in on itself and it's just constantly stabbing me everything I do. It's just the worst.
That's funny. You have boomerang hair.
Yeah.
Boomerang beard.
Yeah. It's bad, like with the mustache, like curls into the mouth, like constantly flossing my own teeth like a beluga whale, just like.
That's funny.
Baleen whale, sorry, but yeah.
John, do you have a question? I see you unmuted the video. Is that like there's a question on the way?
Yeah, I was gonna say, would you consider someone a beginner based on how much time they've been doing an exercise, or based on how much they can like lift? So like, would you consider someone who's been benching for say a month but they can bench 135 versus someone who's like been benching for a year but they can only bench 95? Like, who would you consider the beginner in that situation?
I would consider the beginner the person who hasn't done it for very long, because the tissues just haven't reinforced themselves. The other person may just have all type 1 fibers, or that person may just be like tiny in stature, or they're training badly, but their tissues have still been exposed to that stress, and so they've reinforced. Some of those corresponding tissues can maybe endure a little bit more load without popping, without not necessarily popping, but without experiencing breakdown. And so yeah, the duration of exposure, um, the characteristics of exposure, duration of exposure, that's really going to determine whether somebody is a beginner or if they're sort of intermediate or advanced, and is what those tissues have seen before. Now, if somebody has, they trained for a year and then they took a year off, all right, like you're a beginner again. Maybe there's some myonucleic difference or something. So like, okay, your growth ceiling, whatever, is a little higher, or something like that. Fine, yeah, but the tissues have probably just kind of reverted back to baseline status at that point. And some people are just naturally strong, but those people, they'll get really sore if they use that natural strength to the full, duration of a workout.
Gotcha. Okay.
Should we get out of here? Reconvene on Wednesday. We'll go through supplements on Wednesday, and then Friday we'll do finish supplements and do a little reviewing, whatever questions everyone has. But that's really the last of the serious mTOR stuff. We'll talk about how supplements might interact here and there, those points of contact, but the map. All right, I'll see everybody.
All right, see you.